All right. Yeah, quite an expert. I definitely did not install it today. So, again, I should make sure everyone was good. My project was making a temperature taker, like a digital version that reads the temperature of the room and then flips out when it reaches a certain point, and reaches that point and then sends a signal to my phone, and my phone, well, through Bluetooth, and then my phone in turn sends out an email to me. So, let me just quickly go over the quick setup stuff. Software. There's three elements to this project that comprise the software: your Arduino, the IDE. It's programming software. It runs either with C or Java depending on which branch you are picking up. But I use that to program the board that you can see right here. And if you can't see it, I'm sorry, my cord's not that long. In addition, I use IFTTT, the if this then that, which someone used earlier. I don't know who it was in someone's presentation earlier used that. That's hooked up to, that's what I use in order to send out the automatic email. What happens is with the board, when the board reaches a certain temperature, it turns on this Bluetooth adapter that I have in the back of the machine. And when that turns on, my app that I've developed using MIT's App Inventor connects to that, figures out, oh hey, Bluetooth is on, means the temperature's on. Therefore, it then uses IFTTT to send an automatic email out to me. It's like a giant, 5-step process that should not be 5 steps, but I only wanted to spend $30, so I did. Hardware components, as you can maybe see, depending on how far back you are, depending on how close you are, I used an Adafruit Circuit Playground. This was from DigiKey. I went to one of the presentations and they gave it to me for free. Lucky me. It also came with a battery pack as well, so that's cool. A wearable Bluefruit LE, which is if you guys don't know the difference between Bluefruit and Bluefruit Low Energy, Bluetooth and Bluetooth Low Energy, the big deal is that Bluetooth Low Energy is better. If I was going to boil it down, that's what it's going to be. It's better. It uses less energy. It's better for IoT. Good stuff. And alligator clips, because I didn't want to solder anything together, so I just use alligator clips to hook everything up. So this is how we pin it up. We have the power running from the circuit playground, power on the Bluefruit. This is called Bluefruit, by the way. We got the mode pins being connected, the ground pins, and the RX to TX, the receiving and sending pins on either board. Those are interchangeably set up so that it's more like a one-to-one communication between them. So I just want to quickly also highlight this because I thought this was fun. This is pretty much all the code that I needed to do for the circuit playground board. It's really not much. I mean, everything above that point is just like some definitions and stuff. It's easy. But in comparison to that, the code that went into making the app, as you can see, is a lot. There's a lot more to this. It's zoomed out simply to show the scope of it all. If you guys don't know how to use MIT App Inventor, look it up. It's super cool. So I'm going to quickly demonstrate this thing working. And thank you. That would have been embarrassing. Like I said, I use MIT's App Inventor, so I have an app on my phone that I made myself. And with this thing on, and this thing blowing, presumably.
Is it plugged in?
Yeah. Do I have to press this on here? So, again, I have the temperature sensor right here. Let me just open up my app. So this will begin reading. And begin. As you can see, this thing is lit up because the temperature reaches to a certain point. And my app says, congratulations, you just sent the email. Let's go check that. Would you look at that? Attention, idiot, your server's on fire. And just to prove a point, let me just delete this. I noticed, I said earlier how it's kind of a bit awkward how like, oh hey, you guys probably can't see this because it's hooked up to my machine and the cords are small. let's just do this. Let's unplug it, turn on the battery, and show if this thing can work portably. So let me just turn off that. The temperature has to get lower. So right now it's trying to cool down because I have it set so that I can reset it, but only if the temperature reaches a threshold that it's no longer freaking out. So just give me a second. I wish I had a way to check the temperature of this as it stands. What was that?
Sticks in the fridge.
Yeah, do you have a fridge nearby?
Not that I would share.
Oh, wait, does this have a cooling thing, right?
I don't think it cooled down. It's just blowing up, but like.
Alright, it seems to finally, oh. Come on.
There you go. That's the technique.
It's like it really wants to be cool. Well, anyway. So, as you can see, I just want to show this. This thing is on, it's blaring because it reached that temperature threshold. And on the back, the Bluetooth thing has been turned on. Okay? My app, it'll check for when that thing turns on, and when it does, it'll connect. Once that connects, the app sends out the IFTTT sending an email out. Like so. I can even pass this around if you guys want to see. So it's a combination of IFTTT, Bluetooth, and web services. It's a really overly complicated hurdle, but it works. And if we're going to talk about business applications, well, server rooms. You want to check the temperature of the room, make sure everything's hot and all good, not burning. This is a great way to do that. And because it's portable, it's even better to look at. And you can tell I really care about how fragile everything is because I use Scotch tape to keep it all together. So, yeah. Is there any questions about this? Yeah.
I know there's a threshold of what you tell it to.
Oh yeah. So I set it at 84, but I can change that in the code here if you want to take a look.
Can you add that report to your email? What the current temp or the temp that it's
In the
currently
email?
and give updates to it?
Yeah, I can set the body in the MIT App Inventor. I have it set to just send a stock message, but you can have a variable that changes depending on what comes in. So that's actually not the hard. I haven't just because I just didn't think about that bit, but you can do that. Yeah.
2 questions. Is the box just for structural support?
Yes.
Okay, the battery's in there. It's kind of fun. And then 2, with MIT App Inventor, I've used it myself, but is there a way that you can make it so that the app can run in the background or no?
Yep. In fact,
Okay.
if you mean like if I just close the application?
Yeah, right. No, continue to run.
I know you can. I have not tried it for this, but I know you can.
Okay, I just didn't know if it was gonna still send that.
And if you press the, I think it's at number 14, if you press one of the left or right buttons on that machine, it should probably be cool at this point. Okay. And what was your question? Yeah. That's definitely where the improvements would come in. I said I wanted to spend only $30 on it, and I did, but that would probably melt if it was at 100 degrees Fahrenheit. If the box itself, the cardboard box, would catch fire. Yeah, at that point, that would melt. There's no doubt. But, that's something that I would want to look at for improvements in the future. It's more, as we're talking about, proof of concepts and how this all works. So, yeah, exactly. And like I said, if you have the box with you right there, if you press down, you see like those on the circuit playground, there should be 2 buttons on the front.
Yeah.
Press down both of them. All right, it should be cool at this point, right? Yep, stop. So it works. And then as soon as it reaches temperature again, it'll light up, it'll send an email, it'll send a signal to my phone, and then boom, another email saying my server's on fire. So that's my presentation.
Hey, anybody else got any more questions? Okay, stop your recording.
Yep.
I'm gonna go on a tangent.
Okay.